It could detonate and obliterate all of New York City, along with parts of Connecticut and New Jersey. This is perhaps one of the best-kept secrets in material science. Betelgeuse, a divine marvel adorning the night sky, is a notorious red giant star located in the Orion constellation, captivating stargazers for centuries. Recent updates from renowned physicist Michio Kaku have raised concerns, suggesting that Betelgeuse might be on the verge of exploding. This explosion could reshape our understanding of stellar life cycles and the forces that shape our universe, raising significant questions about its implications for us. Imagine gazing at the night sky and spotting a brilliant star in the Orion constellation. Betelgeuse, also known as Alpha Orionis, is a massive star in Orion, positioned at approximately 5 hours and 30 minutes right ascension and 0 declination. The constellation Orion derives its name from the legendary Greek hunter in mythology, known for its brilliance. Orion boasts several notable stars, with Betelgeuse standing out as a variable star with a distinct reddish hue, ranking as the 11th brightest star in the sky with a magnitude of 0.6. Betelgeuse is the brightest star in Orion, shining like a beacon on the hunter's shoulder. The name Betelgeuse originates from the Arabic phrase, Bat al-Jawza, meaning the giant's shoulder. In 1603, astronomer Johann Bayer assigned the star its unique designation, Alpha Orionis, signifying its status as the brightest star in the Orion constellation. Interestingly, despite its current recognition as the brightest star in Orion, Betelgeuse retains its name with pride. This colossal star has a mass about 20 times greater than that of our Sun, making it a giant when compared to our solar system. To put it into perspective, if the Sun were a small marble, Betelgeuse would be the size of a basketball. Determining Betelgeuse's distance has proven challenging, with estimates placing it between 500 and 600 light-years from the Sun, an enormous distance in cosmological terms. In terms of brightness, Betelgeuse shines brightly with an absolute magnitude of around -6. Harvard astronomer Morgan McLeod notes that Betelgeuse's size and proximity make it one of the few stars that astronomers can closely examine using telescopes from Earth. Telescope images reveal Betelgeuse's unique features, showcasing a surface that is distinct from our Sun's smooth appearance. Instead of a uniform disk of hot plasma, Betelgeuse displays a variety of uneven, bubbling gas pockets, some comparable in size to small stars. Massive upwellings of hot material rise from Betelgeuse's core to the surface, resembling vast boiling springs. It is so enormous that traversing just one of these bubbles at the speed of light would take 75 years. This process, known as surface mass ejection (SME), expels material from Betelgeuse's outer layers, akin to the Sun's coronal mass ejections. Despite its youth in cosmic terms, Betelgeuse has already exhausted the hydrogen fuel in its core, entering the later stages of its existence as it transitions into the red giant phase. During this phase, Betelgeuse fuses helium to produce carbon through fusion processes, marking a rapid evolutionary journey fueled by its substantial initial mass. According to researchers, Betelgeuse began its life as a blue-white O-type star, belonging to the most massive category of hydrogen-burning main-sequence stars in the galaxy. The size of a star is directly related to its brightness and temperature. Larger stars like Betelgeuse shine brighter and burn hotter, but this also leads to quicker hydrogen consumption and an earlier transition to the red giant phase. Betelgeuse's surface has reached staggering temperatures of up to 89,500 degrees Fahrenheit, a stark contrast to our Sun's temperature of about 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and started fusing helium, its outer layer expanded significantly, making it one of the largest stars we know, with a diameter exceeding 700 million miles. Currently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun, yet it shines 7,500 to 14,000 times brighter. In 1836, astronomer John Herschel noted variations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with periodic changes and sporadic fluctuations typically following a 400-day cycle and approximately a 5-year cycle. In the autumn of 2019, Betelgeuse exhibited unusual behavior, deviating from its typical patterns. Its brightness fluctuated significantly, dimming by about 60%, which marked a departure from its regular behavior. This phenomenon was linked to a massive ejection of material that formed a vast dust cloud, obscuring our direct view of the star. Although the dust cloud has since dispersed, Betelgeuse has not fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. This erratic behavior sparked discussions about the potential for an imminent supernova explosion. As Betelgeuse consumes its remaining fuel, its core will collapse, leading to a supernova that could expel its outer layers at speeds of up to 25,000 meters per second. If Betelgeuse were to undergo a supernova explosion, it would create a spectacular display visible for several weeks, comparable to the brightness of a full moon, due to its proximity of only 650 light-years. While supernovae are common, they are often too distant to be observed without powerful telescopes, making Betelgeuse's potential explosion an extraordinary event for night sky watchers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. The most recent notable supernova, SN 1987A, occurred in 1987. A supernova approximately 168,000 light-years away was visible to the naked eye, providing significant insights into stellar evolution. This event was the last recorded supernova before Johannes Kepler's observation in 1604, outshining all other stars in the sky, even during the day. Despite its great distance, it had a considerable impact on Earth. Betelgeuse, a star of particular interest, is expected to undergo a supernova explosion. Miguel Monter, an expert on Betelgeuse, predicts that its brightness will rival that of the full moon when it detonates, leading to a fascinating 2-month period where one could read a book illuminated by the glow of the supernova on a clear night in a dark city. In 2021, Betelgeuse experienced a dimming event similar to the 2019 phenomenon, with a brightness reduction of about 60%. This dimming was attributed to a cloud in the star's wind obscuring part of it, creating a missing southern hemisphere in images. Following this dimming, Betelgeuse unexpectedly brightened by 50%, leaving scientists puzzled about the cause. Currently, Betelgeuse is estimated to be 15 to 20 times the size of the Sun and falls into the category of stars predicted to go supernova. Astronomers generally suggest that Betelgeuse could explode within the next 100,000 years. However, a recent study by Hayuki and colleagues from Tohoku University suggests it may be in a more advanced stage, closer to exploding. Nevertheless, there are differing opinions on the validity of this conclusion. Hayuki's team bases their statement on Betelgeuse's pulsating behavior, which shows periodic expansion and contraction. While they do not predict an imminent explosion, they propose it could occur within the next 1,000 years, challenging previous assumptions about longer timescales. The uncertainty surrounding Betelgeuse's timeline has become a focal point for astronomers as they attempt to predict the star's future. Many researchers are particularly interested in how long it will take for Betelgeuse to end its life in a spectacular supernova. Some estimates suggest it could explode within the next 100,000 years, but debate continues about this time frame. Massive stars like Betelgeuse typically consume their fuel quickly, but in this context, quickly could still mean a span of many years. Some scientists argue that such stars can survive for over 10 million years before collapsing, and while that might seem like a long time, it is relatively brief in the grand scheme of the universe's 13.8 billion-year history. The mystery surrounding when exactly Betelgeuse will explode has prompted astronomers to look for signs, particularly by closely monitoring the star's appearance. One promising indicator of Betelgeuse nearing its final stages is a potential change in its color. A star's color provides crucial information about its temperature, age, and life phase. Red supergiants like Betelgeuse are in a late developmental stage, having already consumed the hydrogen in their cores and are now fusing helium and heavier elements. As a star approaches the end of its life, internal changes can alter its external appearance, including its color. Interestingly, ancient writings describe Betelgeuse as having a more yellowish hue, similar to Saturn, rather than the deep red we associate with it today. Early Chinese, Roman, and Arabic astronomers referred to Betelgeuse as yellow or orange, contrasting with modern perceptions that identify it as distinctly red. This historical discrepancy has led scientists to investigate whether Betelgeuse has indeed changed color over time. If it has, This could suggest that the star has evolved more rapidly than previously thought. A shift from yellow to red could indicate that Betelgeuse has transitioned from an earlier phase in its life cycle to its current status as a red supergiant, potentially signaling that it is closer to exploding than once believed. The possibility that Betelgeuse has experienced such rapid evolution raises important questions about how stars age and die. If the color change is genuine, it could serve as a valuable clue to help researchers better understand the timeline of when the star might explode. Astronomers rely on observations like these to ascertain the final stages of massive stars' lives, using color shifts as a diagnostic tool to gauge where a star is in its evolutionary process. Despite the uncertainties, one thing is clear. When Betelgeuse finally does explode, it will be one of the most spectacular cosmic events ever witnessed by humanity. Its proximity to Earth means that the supernova will be visible to the naked eye, likely shining as brightly as the full moon. The explosion will illuminate the night sky for an extended period, providing a unique celestial display. Whether Betelgeuse detonates soon within a few thousand years or takes its time and stretches its final phase over the next 100,000 years, humanity will be poised to witness the dramatic end of one of the universe's most intriguing phenomena. It promises to be a breathtaking testament to the variety and power of the cosmos, offering both scientists and casual stargazers a chance to marvel at the incredible forces that shape the universe. If Betelgeuse were to go supernova, it would be one of the most dramatic astronomical events observable from Earth in recorded history. The explosion of a star as massive as Betelgeuse would send shockwaves through both the scientific community and the public, igniting awe and wonder as people around the world witness a spectacular transformation in the night sky. The idea of a supernova, a powerful cosmic explosion lighting up our skies, has long captured the imagination of astronomers and enthusiasts alike. Simulations of supernova events have been instrumental in helping scientists understand what such an event would look like from Earth. Based on these models, when Betelgeuse explodes, it is expected to shine with a brightness comparable to that of the full moon or even brighter, creating a second sun-like object in the night sky. Given that Betelgeuse is relatively close to Earth, approximately 500 to 650 light-years away, the explosion will be clearly visible to the naked eye. This supernova will be one of the most fascinating celestial occurrences that humans can observe without the aid of telescopes or other observational instruments. For days or even months, the night sky will be dominated by the brilliant glow of the exploding star, outshining every other celestial object except for the sun. The explosion will be so bright that it will be visible not just at night but also during the day for a significant period. The brightness of Betelgeuse's supernova is expected to match that of the full moon, casting shadows and illuminating the Earth in a soft glow. This dazzling display will persist for some time before gradually fading over the following months to a year. Ultimately, after the initial brilliance diminishes, the remnants of Betelgeuse will be visible as a faint ethereal cloud, a beautiful and enduring reminder of the star's explosive demise. Despite its stunning visual display, Betelgeuse's supernova would pose no significant threat to life on Earth. Recent research indicates that a star must be within approximately 150 light-years of Earth to have a noticeable impact on our planet's environment. With Betelgeuse sitting roughly 500 to 650 light-years away, it is well outside this danger zone. This means that while the explosion would be an awe-inspiring sight, it would not pose any serious risk to life on Earth. In contrast, historical evidence suggests that supernovae closer to Earth may have had more substantial effects. For example, around 2.5 million years ago, a supernova is believed to have contributed to a mass extinction event during the late Pliocene epoch, affecting marine life. The high-energy cosmic rays from that explosion may have disturbed Earth's atmosphere, possibly leading to changes in climate or other environmental factors that played a role in the extinction of species. In the case of Betelgeuse, however, no such threat exists. While the explosion will release a tremendous amount of energy, including gamma rays and ultraviolet radiation, its distance from Earth will prevent any severe damage. There might be a temporary depletion of the ozone layer due to the blast, but this effect would be minor and short-lived, with no lasting harm to the environment or human health.